I'm Swapnil sir, and we are here with the previous year questions from JEE Advance. I already uploaded plenty of the videos on my channel, which is completely based on JEE Advance mains and CT other too. So in my today's video, I'm gonna explain to you all one of the previous year question from JEE Advance, which is completely based on conic sections. And within the conic sections there is an ellipse point there. So our today's question from JEE Advanced, which is mostly based on the ellipse point. So for solving our today's question, we need to know first of all eccentricity, latest rectum, and some other result like area of a rectangle and so on. So let's get start our today's lecture. First of all, I'm going to explain to you all the question, and then we'll go for the detailed understanding of each and every step in our solution. Let's read the question. So in our question we have given equation of an ellipse. Okay, so E1 is the equation of ellipse. It is given, which is x square by 9 plus y square by 4, which is equal to 1. Similarly, the equation of a ellipse which goes to E2, that is the second equation of ellipse, E2, again third equation of ellipse, E3, till end, En. Okay, equation of nth ellipse also given, which is x square by an square plus y square by bn square, which is equal to 1. So these are the n ellipse given. All are the inscribed ellipse. Okay, the ellipse under ellipse, ellipse, ellipse. Okay, so all ellipse are merged together, and then inside ellipse we have given the rectangle ABCD. Okay, that means R1 it is given a rectangle ABCD with the largest area. So R1 is completely inscribed in ellipse E1. Similarly, R2 rectangle, which is completely inscribed in ellipse E2. Similarly, R3 rectangle, which is completely inscribed in ellipse E3. Okay. Similarly, till end, Rnth rectangle, which is completely inscribed in ellipse Rn. Okay, En. Okay. So these all are the given thing, and then we have to find out which one of the option is correct. Okay, so first option, it says that the eccentricity of E19th ellipse. Okay, the eccentricity of E19th ellipse and the eccentricity of E18th ellipse both are same. Okay, that means we have to find out the eccentricity for E19th ellipse and E18th ellipse. Okay, so for finding E19th and E18th, so we need the values for A and B which associated with the eccentricity of E19th ellipse and E18th ellipse. Okay, so it is option, and option number B given length of a lattice rectum of a E19 which is a 1 E9 which is 1 by 6. Okay, so we have to check whether E9 has a lattice rectum 1 by 6 or not. C option is given the summation of n which is equal to 1 to n. So n area of a rectangle is given. Okay, when we add all the n area of a rectangle Rn is the area of a rectangle, nth rectangle. Okay, but here we have given summation, that means we have to add all area of a rectangle, like area of a rectangle R1 plus area of a rectangle R2 plus area of a rectangle of Rn. Okay, and which is a lesser equal, but it is by mistake given that is strictly less. It is not strictly less, it is a lesser equal. Okay, which is a 24, and for each and every integer from n. Okay, so n it is taken from the natural number, so it is all integer from n. Sorry, it is all integer from n. Okay, integer means all positive number and as well as negative number. Okay, n denotes all integer. So option C says that summation of all our rectangle, area of a rectangle which is a 24 or smaller than 24. Option number D, it says that the distance of a focus from the center in E9 which is a root 5 by 32. Okay, So here we have to find out foci. So let us see all the 4 options we have here. We'll see each and every option in detail. We'll understand first of all the concept what we have given. We'll go through the formulas which needed in our example, and then we'll go for the detailed solution. Now let's get started our today's solution. In our solution, we have given first ellipse E1, which is a x square by 9 plus y square by 4, which is equal to 1. So E1 it is given as a first ellipse. R1 it is given first a rectangle. Okay, R1 is a given first rectangle. E2 second ellipse, R2 second rectangle. Similarly, En nth ellipse and Rn as a nth rectangle. Okay. So for that you need to know what is mean by area of a rectangle. Already you learned in your previous standard for finding the values of area of a rectangle. We use length into breadth. Okay. So what is mean by a rectangle? Rectangle means opposite sides are equal. Okay. If opposite sides are equal, then other remaining 2 sides are also there. They are also equal. Okay. So rectangle is having 4 type of the four sides. Okay, and opposite two sides are equal. That means one side is a length and another is a breadth. Okay, it is a special type of a quadrilateral. That means it is having 2 sides parallel which is equal, and 2 sides also another 2 side which is parallel which is also equal. Okay, that means area of a rectangle can be found by the result length into breadth. Okay, this is the way to find out length into breadth. So you may see the figure upper here that I represent the value for x, y and the ellipse by using our given information. So here we can see the length inscribed the area of a rectangle. Okay, so we have ellipse and under ellipse we have inscribed the inscribed rectangle. Okay, so for finding the area of a rectangle from our ellipse, we need to find out length and breadth. Okay, so how can we find the length inside the rectangle, inside ellipse? So here we can see if we take the positive distance, we'll get the x, and if we take the negative distance, we'll get the negative x. Okay, so here we observe here we get the 2 times the value of x is a length. Okay, so here we can see the value for x is a 2 times the value, positive value and negative value. So distance always we calculate positive. So the value for x here, length, we can write as a 2 times the value for x. Okay, positive x and negative x, it will give the value for x. That means the length of our rectangle from the inscribed ellipse. Okay, so which is a 2 times x. And the about breadth means here we can take as a height of our ellipse. Here we can see that the bottom part is a negative y and upper part is positive y. So if you want the breadth of our rectangle, so we take 2 times the value for y. Why 2 times y? Because 1 time y is a negative downside and 1 time y is a positive. That's why breadth can be taken as 2 times y, because this is the distance, so negative positive sign doesn't matter. Okay, so I got the length of a rectangle which is a 2 times value for x, and the length of the breadth of the rectangle which is a 2 times value for y. Don't get confused, only the value for x is a rectangle. Okay, it is a 2 times x. Most of the students they make like a 2 only x. Okay, so it is not possible only x. So here it is coming to x because the length of a value 2 times the value for x, it is the length. Okay, so positive negative values are there, that's why. So I got the length and breadth from our rectangle. Okay, and then let's find out the area of a rectangle R1. Okay, it is for the R1. So here we can see that length and breadth I explain over here. The area of first rectangle, I consider rectangle as capital A, which is equal to 2x into 2y. Okay, so this thing is very much important to move further, because this is the initial step that you need to understand it. Okay, so 2x into 2y, so area of a rectangle R1 is equal to 4 times xy. Okay, so I got the area of rectangle R1. So now I want the value for x and y. Okay, why I want the value for x and y? Because first ellipse contain x and y, second ellipse also contain x and y, third ellipse also contain x and y. That is we taken here as a and b. Okay, like a1 square, a1 b1, a1 square, b2 square, because every ellipse is a different here. First ellipse says that x square upon 9 plus y square upon 4. That means x square upon a plus y square upon b, which is equal to 1. Second ellipse, it says that x square upon a1 square plus x2 upon a2 square, which is equal to 1. Third ellipse says that x cube upon a3 square plus y square upon b3 cube, which is equal to 1. Fourth ellipse, it says that x square upon x square y square always remains same here. When ellipse change, x square y square, these two values always remains as it is. But when we move first ellipse to second ellipse, the value for 9, 4, it will change, okay? Because in our nth ellipse given, a n square, b n square, okay? That means a1, a2, a3, b1, b2, b3 and bn. These are the varying values for a and b, okay? So that one is need to understand over here. So here we want the value for x and y, that we will take as a and b later, okay? So for finding the value for x and y, we always use to reduce the value for x and y as a differentiation, okay? So let's get to find out first of all, then I will explain one more time that you may understand it again, okay? So here, so till that it is nothing problem, okay? Area of a rectangle 4 times xy, I got it here. So I want the value for x and y from here. So try to create the value for x or y. So keep x as it is, find out the value for y, or keep y as it is, find out the value for x. Okay, so what I have done here, I did that I kept x as it is and I found the value for y. Okay, now here we can see for value of y, we have to use the equation of ellipse, which is given first ellipse equation here, x square upon 9 plus y square upon 4, which is equal to 1. Okay, so take the all terms out other side, that you will get the value for y. Okay, so y square is equal to 1 minus x square by 9, 4 multiply divide here, getting multiplied. Okay, solve it further, just a calculation part. 9 minus x square upon 9 into 4. Okay, so take the square root from other both sides. Okay, so after taking square root, we will get the y, which is equal to square root of 4 by 9, that means 2 by 3, and square root of 9 minus x square. Okay, so I got the value for y over here. Put this value for y in our 4xy. Okay, so we will get the area of a rectangle R1, which I consider as a, which is equal to 4 into x as it is into the value for y. Okay, so 8 by 3 x into square root of 9 minus x square. Okay, this is the area of a required area of a rectangle. Okay, which is the required area of a rectangle. Now I want the value for x and I want the value for y. Okay, so whenever we have any quadratic equation or any power of equation, what we do for finding the value of x and y, we differentiate that term and we equate that term equal to 0. So after equating, surely only one variable is there, so you will get the easily value for x. Once you get the value for x, put it here into the y, you will get the value for y. Okay, now here our first target is to differentiate a with respect to x and equate it equal to 0. So I differentiated a with respect to x here. So 8 by 3 constant outside, we have x into square root of 9 minus x square. So apply by part rule. By part rule of a differentiation, it says that first function as it is, differentiation of second, plus second function as it is, differentiation of first. Okay, so apply this by part rule, you will get this step. Okay, so this is a quite easy differentiation. I'm not gonna explain this one here, so you may have to understand it. Okay, and equate it equal to 0, then you will get the value for x. So this equal to 0, that means complete equal to 0. 8 by 3 getting 0 here. So 9 minus x square, this into this minus this. So 9 minus x square minus x square, 9 minus 2x square upon square root of 9 minus x square. Okay, this is just easy calculation. Then after of that, we have here 9 minus 2x square upon square root. Take square root here, it becomes 0. So 2x square is equal to 9 and x square is equal to 9 by 2 and x is equal to 3 by root 2. Okay, so I got the value for x is a 3 by root 2. Find out the similar value for y, and y says that y, which is equal to 2 by 3 square root of 9 minus x square. Okay, put x over here. So x square is equal to 9 by 2. So it is here 2 by 3 as it is, 9 as it is, square root of 9 minus 9 by 2. So 9 to the 18 minus 9, 9 by 2. Okay, so you have to find out square root and then you will get the 2 by 3 multiplied by root 3 by root 2. Okay, These are the easy calculations. So 3 get cancelled. 2 by root 2 is the value for y. So here I got the value for x and I got the value for y with respect to first ellipse. Okay, always remember these are the value for x and y with respect to first ellipse. We have given nth ellipse. Okay, n ellipse are given. So that means every value for x and y for nth ellipse like a and b, it will change. It will vary everywhere. It never remains same. Okay, as we have given in question, x square upon a square plus y square upon b square is equal to 1. X square y square always remains same, but the denominator a square b square, that means a1 square a2 square b1 square b2 square, that will change everywhere. So instead of ab I taken xy. Don't get confused over here, because why I taken xy? Because always we differentiate terms in the term of x and y. That's why, to make you all easier to understand, so I made a and b in the form of x and y. Okay, so actually this is the term of a and this is the term of b, which will vary for every ellipse. Okay, so here I got for e1 I got the x and y, that means a and b here. Similarly for e2 you will get the a 2 by 3 by root 2, b 2 by root 2. Okay, so similarly you will get for e2 also. For E3, En, what we have given? Nth ellipse, x square by n square, y square by bn square, which is equal to 1. Okay. So this one is the nth equation of ellipse. So for that we will get the different a and bn. Okay. So for a3, b3 we will get the a is a 2 root 2 square, b is a root 2 square. Then you have to use it here. Then you will get the value for 3 by root 2 third power and b is 3 by root 2, 2 by root 2 third power. Okay. So this will be vary. The power will be changed, denominator power. Okay. 3 2 always remains same over here. Okay, this power will be changed only. Now our first option says that the eccentricity for b, the eccentricity for ellipse E19 and ellipse E18 both are not equal. What first option say? That eccentricity of E19 E18 not equal. So let's check the eccentricity which can be defined only with the depend on b by a. Okay, define and depend on only with the b by a. Okay, because eccentricity we can write e square is equal to 1 minus b square by a square. So eccentricity completely depend on b square upon a square. Okay, so you have to define b by a properly, then only then you can define eccentricity. Okay, so eccentricity which depend upon b by a, that means eccentricity for all terms, how it look like. Just we cannot find directly eccentricity for E19th term or E18th term. So for that you have to visualize what the first eccentricity coming, what the second eccentricity coming, what the nth eccentricity coming. That is the visualization that you cannot go for directly to find out the eccentricity for E15, eccentricity for E18. Any terms are there that is quite difficult to find out the eccentricity for nth term. So for finding the eccentricity, you have to visualize what we have given and how can we form the eccentricity of first, eccentricity of the second, and eccentricity of further term. Okay, so that I visualize over here that eccentricity for the second term 2 by root 2 square, that is a value for b. Okay, 2 by root 2 square, 3 by root 2 square. Eccentricity of the next ellipse 2 by root 2 cube, 3 by root 2 cube, similarly so on. So it seems like that the denominator is changing. It is changing, but numerator remains same. But that we can cancel root 2 square with the root 2 square. It remains 2 by root 3. We can cancel this one. It remains 2 by 3. So it seems like that the all eccentricities which needed b by a for all eccentricity, it remains 2 by 3 everywhere same. For every ellipse, we got the value for b by a, which is a 2 by 3. That means a 4 by 9. So the value for eccentricity for every ellipse, it remains same everywhere. Everywhere it is remains same. Because why? The denominator is get cancelled at every division. Okay, the eccentricity for all ellipse, which is only the value depend on b by a. So b by a it is remains same for everywhere. Okay, so b by a is a 2 by 3. So 2 by 3 always remains same here. So our first option, it says that E19, E18 both have different eccentricity, but never possible. They are the always equal. Okay. And let's find out the eccentricity, what eccentricity is coming. Okay, so here we can see eccentricity. I found here 1 minus b square by a square. Okay, b square by a square, b means 2 square by 3 square, which is a 4 by 9, and 9 minus 9 1 9 minus 4, 5 by 9. Okay, so I got the value for eccentricity is a root 5 by 3. Okay, so eccentricity for all nth ellipse always remains same, and which is a root 5 by 3. Keep in mind, because we need this term in next options. Okay, so first option is wrong over here. So eccentricity for E19 and E18 equal, that they given it is not equal. Okay, so that's why wrong. Now latest rectum. Now we want the length of a latest rectum of E9. Okay, length of a latest rectum of E9. So length of a latest rectum can be found by 2b square by a. Okay, but a b and a will be changed when we take E9th ellipse. Okay, so as we have E third ellipse, that a which is equal to root 3 by 2, root 3 by root 2 bracket square. Okay, so when we have third ellipse, okay, third ellipse already we found. When we have third ellipse, okay, we write the value for a which is 3 by root 2 30 for the third ellipse. Okay, we write 3 by root 2 square. Okay, for third ellipse we write 3 by root 2 square, and b as a 2 by root 2 square. Okay, that means for third ellipse we write n minus 1 power for root 2. Okay, so for n ninth ellipse we write n minus 1 power, that means 8, 9 minus 1 is 8, and 9 minus 1 is 8. Okay, don't get confused. For every ellipse a and b will be vary. Okay, so for nth ellipse we write n minus 1 power of root 2. Okay, n minus 1 power of root 2. So ninth ellipse 9 minus 1 8, 9 minus 1 8 over here. Okay, so I got the value for 3 by root 2 to the power 8 and b root 2 by root 2 to the power 8. Okay, so let us rectum, it says that 2b square by a. So 2b square, just put the value 2 into b square divided by a over here. Just go for the calculation. These are the very easy calculation. I'm not going to explain this one over here. You may solve it your own. Okay, so after solving all these steps we land over 1 by 6. Okay, and which is given in our option B. Or option B, it says that the length of a latest rectum is of E9th ellipse is 1 by 6. Okay, which is correct. So it is very easy calculation. You may do it by your own. Okay, now third option, it says that area of a rectangle R1, R2, R3, when we take all their sum, it coming smaller than 24 for each integer n. Okay, so C is given, n is equal to 1 to n, and all the area of a rectangle sum there smaller than 24. Okay, so now let's see the solution. To visualize our solution, to visualize our option, let us find out the area for each and every rectangle, that general area of a rectangle. Okay, so here area of a rectangle R1, which is a 4 times xy, we know that, and with respect to the value for x and y to our rectangle, which is a 3 by root 2 is x and 2 by root 2 is y. Okay, so after calculating you will get the 24 by 2. Similarly, area of a rectangle R2, 4xy, 4 as it is, x will be R2, means here we have 3 by root 2 square and 2 by root 2 square. Okay, which is 24 by 2 square. Okay, similarly area of R3 we get the 4xy, 4 into value of x, value of y. Okay, root 2 xy will be different. Okay, whenever the rectangle change. Okay, rectangle change when ellipse change, and if ellipse change then value for AB change, and value for AB change then x and y change. Okay, because in a rectangle we denote x and y as a side, and in a ellipse we denote b, a and b as there. Okay, so this is only little confusion, but nothing is difficult. Okay, so these are the all values for area of R1, R2, R3 and so on. We don't need to find further because these values are having some type of the relation between them. Okay, so here we can see 24 by 2, 24 by 2 square, 24 by 3 cube, 2 cube, and you will get the area of R3 24 by 2 raised to 4, 24 by 2 raised to n. This way you will get that. Okay, because these are having some type of relation between them. Okay, that we learn in a geometric progression. Ratio between these terms are similar. Okay, so let's find out the summation for area of Rn, which is a 24 by 2, 24 by 2 square, 24 by 2 cube plus 24 by 2 raised to n. Okay, so 24 by 2 is a 12. 24 by 2 square can be written as 12 by 2. Okay, because we want the term similar that we can find out the easily their addition. Okay, 24 by 2 square and so on. Okay, so here we can see all these terms represent something relation between them. So which is the geometric progression, which is a geometric progression between all these terms. And what the geometric progression, it says that when the ratio between first term, second term, third term, it remains same. When the ratio remains same, then we say that there exists geometric progression. And when difference remains same, then we say that there is a arithmetic progression. Okay, so here we apply geometric progression. So here we can see this is the nth all addition for n term of a geometric progression. And how can we add nth term of a geometric progression? So addition for nth term of geometric progression can be written as first term upon 1 minus common difference. Okay, so first term 12 upon 1 minus common difference, which is 1 by 2. Okay, 12 upon 1 minus 1 by 2, sum of nth term, first term upon 1 minus common difference. There are some other result too that you may apply these ones, but these are the easier that I found that you can understand easily. Okay, so which is a 24. So option number C, which says that area of all rectangle is smaller than 24 or smaller than 24. Okay, that means we have sum of all rectangle, all R1, R2 till Rn, all rectangle is a 24. If we take sum of a n minus 1 rectangle, it is coming smaller than 24. N minus 2 rectangle, it is coming smaller than 24. So n minus any rectangle sum, it is coming smaller than 24 or smaller than 24. Okay, 24 or smaller than 24. So option number C, which is correct. And last option, which is completely based on the focus of ellipse. Okay, so just we have to apply one result, you will get the solution. Okay, so the video already extended much more, so I'll try to take it into the take it into fast. Okay, so here the distance of a focus from the center of E9, which is a root 5 by 32. Okay, so this is given the distance from focus. Okay, root 5 by 32. Okay, so for finding E9, we need A and B for E9. Okay, so A, which is a 3 by root 2 to the power 8, n minus 1. E9 means n minus 1 to the power. E9 means n minus 1 to the power root 3 by root 2 to the power 8. 2 by root 2 to the power 8, and eccentricity everywhere it is the same, which is a root 5 by 3. Okay, and focus can be found by plus minus AE0. Okay, but we want the distance, so plus minus no need to take it because distance always remain positive. So focus AE0, that means A times E and 0 remains 0. A multiplied by E can be written as 3 multiplied by root 5 and root 2 to the power 8 multiplied by 3. 3 get cancelled. Root 5 by 2 to the power root 2 to the power 8. So root 2 to the power 2 to the power 4 we can write it. Okay, so root 5 by 2 to the power 4 is a 16. Okay, so because square root and 2 it will remain, it will get cancelled. Okay, root 5 by 16. So the value for x is a root 5 by 16 and y is a 0. So the distance from the focus, okay, the distance from the focus of a center. So here we have center and the focus, we will get that f here. Okay, so x, which is lies on x axis. Okay, because y is a 0, so distance from center to focus here. Okay, so which is here root 5x root 5 by 16 and y 0. Okay, we no need for y. So here the total complete distance between center to x coordinate, which is a root 5 by 16. Okay, the distance from focus to center is a root 5 by 16, which is option number D, which is correct. Okay, so I hope you all have understood my today's lecture. All the option I explained here in detail. Okay, even after if you found anything difficult, let me know in comment section. So thank you everyone. Thank you for my today's lecture.